Okay, there we go. What was the point of spinning the pennies?
See if there's a difference between flipping and spinning?
Good! Yeah, I think so, right? I mean, the overriding question, Nick, was what's the probability? I think it was getting heads on a spin. Exactly. On a spin. And to see if there is a difference between flipping a coin and spinning a coin. We know from anecdotal evidence and decades, if not hundreds of years of flipping coins, that when you flip a coin, it comes up 50-50. Is there any difference between that and what we get when we spin coins? That was the whole point of collecting the data. So, is it different? Is it different than flipping? Which is 50% of the time you get heads. Is it any different? Statistically, significantly different. I don't know. You click us some data. Remember what we got? I think I wrote it down correctly.
47%.
We had 47%, right? We had 160 heads out of 340 spins. We had, here's our results. Our results were 160 heads out of 340 spins, which came up to a cozy 47%. So we're done. We're done. You call the papers and tell them, yes, indeed, Nick's question has been answered. You get heads less time when you spin than when you flip. Everybody happy with that? I'm not. That's crap. Why is that crap? Oh, good. How big's big enough? This is great. Danielle's got it. Oh, okay, good. Can we hold that question for a bit until we under? There's really two questions at work here. Did we do enough trials? And the answer is either yes or no, depending on some factors. The answer is actually can be yes, as long as you're willing to accept something, which you're not even sure we're talking about accepting yet. The answer is no if you're not willing to accept that. So that's why I want to come back to that, and I want to make sure this first something that it depends on is understood before we get into that question. Thank you, sister. What's another reason why we can't just say it's 47%? 47% done! What's wrong with doing that?
There's a margin of error.
What do we need that for? Excuse me, puberty. What do we need a margin of error for? Oh, okay, good. Danielle's hinted upon something here. Thank you for this. You're actually hinting into your project, which is not due till next week. There are two kinds of error in an experiment. There are what's called sampling error and what's called non-sampling error. Now that's fancy talk for you screwed up the experiment in how you were doing the data. That's called non-sampling error. It means you did something wrong. You either introduced bias, you spun incorrectly, you spun the wrong kinds of pennies. Some of you were spinning 2006 pennies, some of you were spinning pre-2006 pennies, or you were spinning near a crack that grabbed the penny and made it change motion. Those are things that should be avoided experimentally. That's called non-sampling error. I'm going to pretend that that didn't happen in here, because as I was watching you guys spin, it looked like you were all spinning relatively on flat surfaces and there weren't any goofiness things happening. But that's a good point. You should pay attention to that kind of stuff, and your first project has you look at it more deeply. But then there's also something called sampling error. Now what the heck is that? What is sampling error?
Is that the outliers?
Well, they happen naturally, yes. They're part of it. The few of us last time, I believe, got 9 heads out of 10 or one head out of 10. You would call those outlier events because they don't happen very often, but they do happen. So they're going to happen as a natural occurrence in the data. Thank you, Veronica. Alan, what's on your mind?
Well, you could do the same amount of population 10 different times to get 10 different answers.
That's why you need a margin of error. Because if we stop right now and say the answer is 47%, that means we perfectly captured the population in our 340 spins. Is that probable?
No.
It's not probable. Is it possible?
Yes.
Of course, but is it probable? No. Which means, if we were to do the experiment another 340 times, would we get exactly 160 heads again? Of course not. We're going to get probably what? Good, close. Which begs the question, of course, how close is close? And what answers that question? The margin of error. That's the whole point of the margin of error. It talks about how close is close. It's tied to sample size. We'll come back to that, Daniel, I promise. If you don't like 340, of course, more data is better as long as you have enough. As long as the data is good. More data is always better than less data. But you can do wonderful things with small data sets. We'll come back to this. So what I want to do is a quick recap of a visual we saw last week, just because we're going to come back to it over the next couple days together. And this is already posted for you guys on the page. You don't have to write this down if you don't want to. Here you are. Make sure you can see that okay on the camera. We cannot. Back up. Okay, beautiful. So, what we're doing today, Thursday, probably into Tuesday of next week, I'm guessing, if my timeline in my head is kind of playing out. We're trying to estimate a parameter. That's the big idea. We're trying to estimate we're trying to figure out a parametric value in a population. We want to know something. Yeah, this is a bit of a silly example. I got some more realistic data here to play with momentarily. But the idea is somewhere in a population, there is a value you want to know. But you can't actually count the population to get it or measure the population to get it. So you draw, boom, a random sample. Your project for next week delves greatly into making sure samples are drawn properly randomly. Has anybody taken the class research methods here at COCC? Does anybody have to for their major? Okay, that's an entire class devoted to just step 1 up there, which I find fascinating. I find fascinating that it's not a prerequisite for 244 students. I don't know why that is, or I guess I don't know why that isn't. But regardless, there's a lot of care that needs to go into this step 1. I'll keep bringing it up as we go through this course, although it's not a really huge part of this course, but I think it maybe should be. But I'll keep verbally bringing it up as we go. I'll ask you questions like, could that sample have been done better? Are there any problems with that sample? And we'll keep coming into that. Okay, everybody nailed this right away. Find the center of that sample. And there are only 2 centers we're going to talk about. A proportion, or a percentage, and a mean, or an average. Those are the only 2. We're not doing averages today. I'm going to hold those for next time. There's no reason to get into those today. And that's fantastic. As a matter of fact, that's where the news often stops. Congress is now less popular than syphilis. And Congress's approval rating is at 9%. Is Congress's approval rating at 9%? It's at 9%. What are they forgetting? Something or something. Something. Plus or minus something. Some margin of error. Some margin of error around that 9%. And this is often ignored when you read about statistics in mass media. Especially inferential statistics, which is the only place this margin of error exists, is in the inferential part of it. So when you're trying to infer something about a parameter, yeah, the center is important, but just as important, I shouldn't say more, maybe more. Just as important, if not more important, is this plus or minus, the wings, the margin of error that has to go around it. So what we have to do is, we have to now come up with a procedure for developing this for us. We've already got 1 and 2 taken care of. Boom, boom, now we need this guy. Now what I want to do is, I want to take a trip back to 243. At the bottom there I put, remember mu plus or minus 2 sigma. I know the answer to that. You do remember that. You remember the bell curve and 2 standard deviations, and you remember what about that? 95% of your data is going to live within those 2 standard deviations. Okay, that's important. That's important to remember anyway.